Hi, I am Sandra and I want to discuss all about exceptions. Firstly, what is an exception? An exception is when something's gone wrong in your program and you get that red printed out in the console window at the bottom. I'm very quickly going to run this just to show you what I mean, that red that's printed out. So the example that I have here, I've created an ArrayIndexOutOfBoundsException. I have an array with 4 elements in it. So the index to access these would be number square bracket 0 to 1, 2, number square bracket 3. I've deliberately accessed number square bracket 4 and that causes an exception to occur. So that's what an exception is. Something has gone wrong, it's printed out, that red that you see, that's the stack trace down in the console window. So the stack trace tells you what line of your program caused the exception, and then if there's more code it will tell you where that line was called from in your program, or to give you a trace through what method called what method to where the exception occurred. So why are they happening? Well, in this case I've written code that's wrong. It's as simple as that. But exceptions might occur because the user of your program provided data that was in the wrong format or maybe the wrong length, and your program can't deal with it properly unless it receives the values in the correct format. So in that case, you have to deal with the exception from your point of view, but you have to give a message to the user to tell them to fix the problem at their end. Now, there are 2 types of exceptions. Unchecked, so you don't have to write any special code in your program to check for them. They will happen, and in which case print out in the console window. And then we have checked exceptions, which you have to write special code in your program, try catch blocks or declare that they're thrown. You have to deal with it or your program won't compile. And finally, where do exceptions occur? So it's not when you're typing the code. If something went wrong when you were typing the code, like I'll just change that 4 to a letter for instance, then your program won't compile. So it's not at compile time in your code, it's when you hit the run button and it can't attempt to run your code for some reason. So exceptions happen at runtime. Your program will immediately stop running, a stack trace will print out in the console window, you need to read the message, figure out what's gone wrong and fix it. But sometimes it mightn't be your code that's wrong, it might be the user that's supplying a value, and you need to tell them to fix the problem. So we're going to look at these types of exceptions. So that first one I've created is an ArrayIndexOutOfBoundsException. Very common, especially if you're trying to write your own loop to go through the array, and maybe you have I equals 4, I less than 5, or it should have been I less than 4, so your loop is wrong. Another example of a common exception is a NullPointerException. I've created a class here called person, and it has a member variable called name. I have code in main that creates an instance of that person class, calls the default constructor, which there's no constructor there, you get a default constructor provided by the compiler. Nothing gets set up, but the person will of course have a name, but gets a default value of null. Then if I retrieve the person's name and print it out, that'll be okay. I'll just do that here above. So if I print out the person's name and concatenate on that, so that's P is my object reference dot get name. If I print out their name, that's fine, that will print out null. But if I try do a dot on something that's null, so in the next line I'm getting the person's name and then I'm going dot, so I'm trying to get the length, dot length. Once I try and access the null object, I try to access something inside the object, but there isn't an object. So I've essentially gone null dot, I'll get a NullPointerException. So that's a common one as well. Now, the ArrayIndexOutOfBoundsException in the first example, and my now NullPointer in my second example, they're both unchecked. I haven't had to write any special code in the program, like a try catch block or a throws statement. I haven't had to write those. The exception will occur, it'll print out in the console window that stack trace, and I need to fix the problem. So they're the unchecked exceptions. There are other types of exceptions called checked exceptions. Now the third example here, I just uncomment what I have here. Now, in this program, I want to read from a file. My file name is nosuchfile.txt. I'm using try with resources. Inside the round brackets, I'm creating a buffered reader, which you'll use to read from the file. The buffered reader has to be passed in another file, another reader type, and the file name gets passed into its constructor. Now, this isn't compiling. If I hover over unhandled exception, type file not found. If I hover over here, the try with resources attempts to do a close, might not be able to close the file, then that causes an IOException, and my read line, another unhandled exception, another IO. So in this example, it won't compile unless I deal with those exceptions, and they are called checked exceptions. Now I'm going to go to a diagram that I have. So here, in the API, the top of the API, there's an object class. Down from that, throwable. Down from that, errors. You can't deal with them. There's something seriously gone wrong. You can't deal with errors. You just let those happen and try and fix it. Could be out of memory, like normally it's something serious. And then we get to the exceptions. So I've made two subclasses of this. On the left-hand side, there is a class called RuntimeException, and there is a class called RuntimeException, and anything that extends RuntimeException is known as unchecked. Just let it happen, read the stack trace, and fix what you've done wrong. That's the likes of the ArrayIndexOutOfBounds and the null pointer. There's the other exceptions. They extend directly from exception, so they are a direct child of exception, or they might be a subclass of another exception, so they might be somewhere down the hierarchy. But the exceptions on this side don't have runtime in their hierarchy, and they are unchecked, such as FileNotFoundException, IOException, and when we get to databases, there's going to be SQLException. Those you have to check for them. You have to write your try-catch block, or there's another way, which is declare it, and I'll look at that at the end. Now, I've opened up the Java API just to show you what I mean by the checked and unchecked exceptions. I am in the Java lang package. I have scrolled down and opened up RuntimeException. So anything that is a subclass of RuntimeException will be unchecked. Your program blows up, you need to fix your problem. So for example, if we have a look here, arithmetic exception would be divide by 0. And I won't bore you anymore there. I'll go into the IO package here for a second and scroll down to FileNotFoundException. There you are. So in FileNotFoundException, if you have a look up here at the top, you can see that RuntimeException is not in the hierarchy. So when RuntimeException is not there, they are checked exceptions, and your code won't compile until you deal with it. Now, back to my example here. So to deal with it, I have a try block here already, so what I need to do is put in a catch. Now, there are two exceptions that could be generated from here. The file reader generates a file not found, and the read line an IOException. So I put in a catch and round brackets, file not found. Print out here, file not found. Now, if this is to happen, I still like to do an e.print stack trace to print out still the stack trace, so I can read it as a programmer and go, oh, file not found. Oh, okay, I've spelled that wrong, or oh, I forgot to create it. Or maybe in this example, the user didn't provide you with the right file name. You gave them a dialog to open up the file and they didn't choose the right one, or they typed one in that doesn't exist. So you'd need to alert the user. This still won't compile because readline might produce a checked exception as well, and that's IO. So catch IOException. And in this example, this would be, sorry, let's put in syso instead. This one would be an error reading from file. So it's able to open it, but for some reason it can't read from the file. And again, e.print stack trace, just so I can see what's gone wrong. Now I'm going to run this code. Now, on the line here, line 20, the file name doesn't exist. So from there, it's going to jump down to the corresponding catch block, and the catch block that it's going to go to is the first one, FileNotFound. It'll print out FileNotFound, and then it'll print out the stack trace so I can read this. The system cannot find the file specified, and then you might realize, oh yeah, that file doesn't exist. After the catch block has executed, only one catch block will execute. It will go to the code afterwards, so your program will carry on once you catch the exception. Whereas the other two examples I have, the program won't carry on. It will bomb out and you need to fix the problem. So I'll just put in a print line here. So end of the program. Your program carries on. So when you catch the exception, you somehow need to deal with it or present the user with a message that a GUI might appear and let them deal with the problem or let them try and fix the problem at their end. And now we have end of program. Now, there's something else that you need to know here. The order of these catch blocks is very important. Now, FileNotFound is a subtype of IOException. And the rule is you catch the subtypes first and the parent exceptions second or last, in this case second or last. If I swap those around, so wait till I just cut that out, move the FileNotFound, and that was IOException there. So if I swap those around and IOException is a parent of FileNotFound, well, in this example, FileNotFound would be caught by that IOException, and therefore the code down here is actually, it's unreachable. So you can't put the parent type first, because then it won't, the child types aren't, it's not possible for them to execute underneath. So you might think, we should just stick in the parent, and then I don't need to bother with the one underneath. That's bad programming, because now you don't know exactly what happened if it went into the IOException. It might be a case that the file wasn't found. It might be a case that it couldn't read from the file. So you need to alert the user exactly what's gone wrong. So that's not good coding practice. So I'll just swap those back. So more specific, child first, parent second. And finally, you can put on a finally block at the end of the catch. So a finally block will always execute. It always happens after the try, after the catches, if they occur. And it's typically used for closing connections. Closing connections, like closing a connection to a file or closing a connection to a database. The finally block existed before this magnificent try with resources, which will automatically close any connections for you. So the finally block, there probably isn't a whole lot of point to it because the try with resources is taken over. But just know that a finally block has to be last and it will always execute even if an exception does occur. Now there's one last thing that I need to look at. In this example here, main calls the method read that file. Read that file attempts to read to a file, and the try catch blocks are inside there. Now I've copied the bulk of this into another file here. I've just removed the catches. Now again, the file reader might throw a FileNotFoundException. The read line might throw an IOException. So when you write code that calls a method that might throw a checked exception, you have to deal with it. There are two ways of dealing with it. One I've done already, and that's use your try catch blocks to deal with it. And the second one is not to put try catch blocks in here, but the method in its signature, so where the method first line is, it declares that it might throw those exceptions. So the way it does that is the keyword throws, and it might throw two exceptions, so you're better off declaring the two of them, even though I could just write the IOException because that's the parent, but you're better off saying it might throw a FileNotFoundException and a comma, and it might throw an IOException. So when you call code that might throw a checked exception, you need to deal with it. Either the first example I've discussed already, the catch blocks, or this method declares that it might throw either a file not found, because it can't, there's no such file, or an IOException, because for some reason it can't read from the file. And now, on line 12, same rule again. I'm now calling a method that might throw one of these two checked exceptions. So now the rule is put a try catch block around that calling code, or the method that it is in declare that it might throw the exception. If I throw it straight out here, now I'm going to cheat here and just put the parent of the two of them. So now main is saying it might throw an IOException. So now the code that calls main has to deal with the exception. What calls main? The Java virtual machine. Does it do a try catch block? No, it just prints the stack trace. So if I run this program, there's no try catches. So what main will do is, so essentially it has or what the JVM will do, essentially it has a try catch block around that code, and it does a print stack trace. So in this case, no such file. So that is when you call code that might throw a checked exception, put a try catch block around your code or declare it. The only reason that I think that I would declare it as opposed to the try catch block is if I'm writing a file like a database manager and I don't know where it's going to be called from. It might be called from a graphical user interface. It might be called from a console application, in which case I don't know, does the user want to display a message in a graphical format with a message box when they catch an exception? Or do they want to print it out into the console window when there's an exception caught? Or do they want to log it in a log file? So in that case, when somebody else is going to be calling your code, that's where you declare it. If you know you're writing the whole application, in which case, in the previous example, if it was a console application, well then I would be doing the system.out.println. So that is exceptions. So if you want to hang on, I'll just do a summary. So exceptions occur when something has gone wrong in your code or gone wrong with information maybe provided to your program. Exceptions happen at runtime, not when your program's been compiled, but when you run your program, and when something's gone wrong, it'll print out down in the console window, which is known as the stack trace. In this example, there are checked exceptions, so if no try catches, they will just happen. You need to read what's gone wrong and fix the problem. They're unchecked. No try catches, fix the problem. And then we have checked exceptions. So dealing with files or databases, there will be checked exceptions where you need to deal with it in your program. When you deal with it, you have two options, the try catch block, but when you catch it, you provide a message to the user to tell them what's gone wrong and see if they're able to fix the problem. Maybe they provided the wrong data type or not the correct length of information, or maybe they got their username and password incorrect. So you need to give them a message and see if they can fix the problem at their end, and then you rerun the code again. When you catch an exception, your program carries on. If you don't catch it, like the array index out of bounds, your program kind of crashes out and it's no longer running. And then the last example, when a method calls a method, so main calls a method, and inside that method, it might throw a checked exception. There's no catches here. The other option is to declare that it might throw one of these two exceptions. And now the calling code, same rule, try catch around it or declare that it might throw it. When you throw something out of main, the Java virtual machine will simply print out the stack trace. And again, the program doesn't carry on because it wasn't caught, it wasn't dealt with, a message wasn't provided to the user. And that is exceptions. Thank you for listening.